Hi everyone, it's Mr. Cash and welcome to this video called the liter and the milliliter. So we're going to talk about those two measurements, but first I wanted to go back a little bit and talk about a different kind of measurement that we've already done in class, just so that we can kind of connect them together when I talk about the liter and the milliliter today. So you remember the meter. So this is a meter stick. It will not fit all on the video because it's a whole meter long, but it is a full meter, and we've used the meter sticks at school to measure things. The symbol for the meter is M. But what I wanted to talk about is, while this is 1 meter, if I could take maybe a really sharp knife or a saw and cut this up into 1,000 equal size slices, each of those slices would be called a millimeter. The millimeter is just the distance between any of these two lines here. But it's about the thickness of a fingernail, which we've talked about a bit at school. Or if you've got, some sort of a credit card, maybe your mom or your dad or whoever takes care of you has a credit card like this or a points card, the thickness of those cards, those cards are about a millimeter thick. So if I had 1,000 of these and I stacked them up, they would go as high as this meter stick. So now I wanted to talk about the liter and the milliliter. Milli means that you've divided something into 1,000. So if we talk about 1 liter, so this is the glass measuring cup from the last video. If I put this in behind here, you can see this a lot more clearly. This measures water or liquid or whatever you want up to a capacity of 1 liter. So if I were to take this measuring cup and I filled this up with water all the way up to 1 liter. So I'll bring this back. So now we can see that the water level has been filled up to 1 liter. So there's 1 liter of water. Now if we were to take out 1/1000th, if we were to divide this volume of water up into 1,000 equal parts, we would want to take out 1 milliliter of water. So this is an eyedropper, and again I'll use this to try and make it more clear on the video. So if I bring this a little bit closer, this eyedropper, it's just a glass tube and a squeezy thing at the end that you put eye drops in, or you can use it for lots of different things. This eyedropper is special. It's graduated, which means it has lines here so that you can measure how much liquid you are putting in the eyedropper. And this symbol here, ml, stands for 1 milliliter. So if I were to take some of this water out using the eyedropper and fill it up to that line, we would have 1 milliliter of water. And I want to put that in my palm of my hand so you can see how much that is. If we were at school during this time, this is something that we would be doing at school. So I'm going to take a little bit out. Now that's more. I've taken more than a milliliter out, so I need to get some of the drops out. I can see here with my eyes that the water level is at 1 milliliter. So now there's 999 milliliters in here. It's not a full liter anymore. So I'm going to put this amount of water in my hands. So here we go. So there we are. So you can see that this is more than 1 drop of water, but it's not a lot of water. That amount of water is 1 milliliter. It's a very small amount of water. So an interesting thing about 1 milliliter of water, this is a really interesting thing. At school we've got little packages like this. These are called centicubes, and that's because each of these cubes of plastic that connect with these little knobs here, sort of like Lego, I guess, each of these cubes is 1 centimeter on every side. So it's a 1 centimeter cube. So here's the interesting thing about 1 milliliter of water. If somehow I could shape this water into a cube, it would be exactly this big. And this is a very important thing that scientists and mathematicians use every day. The volume of 1 milliliter of water is 1 cubic centimeter, but there's something else that's really interesting about 1 milliliter of water, and that has to do with mass. So when you're measuring mass, you use a scale. So this is a digital scale, so you put your masses here. So anything you want to measure the mass of, you can put on top here, and it will show the amount of grams. So a gram is a measurement of mass. So when you get scales like this, you usually get these metal weights or metal masses, and they have numbers written on the top that shows you how much they are. So this one says that this mass is 20 grams, and this allows you to test out your scale to make sure it's working right. So when you look at this one, there's a 5 on the top, so that says that this is 5 grams. So this should show 5.0 when I put this on the scale. So let me take the 5 grams off. Here's one that's 1 gram, so this is a 1 gram weight. So that says 1.0, and that's good. So that tells me my scale is working okay. I'm going to take 1 milliliter of water again, and we're going to measure the mass of 1 milliliter of water. And this is also a very well-known and important thing that is true about 1 milliliter of water. So I'm just trying to get it right here. So let's squeeze out 1 milliliter of water onto the scale. And when you squeeze that out, you can see that the weight shows 1.0 grams. So that's the really important thing to remember about a milliliter of water. And this is something that you don't really have to learn about in grade 3. You talk more about it in grade 4, 5, 6, 7, and other grades. And scientists and mathematicians all over the world know this and depend on this every day in their work. So here's the main idea again. 1 milliliter of water equals 1 gram if measured by mass on a scale. And also 1 milliliter of water, the volume of that 1 milliliter, if you could shape it into a solid object, would be exactly this size, without that little bump there, of course. This is a 1 centimeter cube. So if I measured all the sides, every side would be 1 centimeter. Hi, it's Mr. Cash, and I'm in my kitchen, and I'm looking around at all the containers that I have in cupboards and things, because I'm really curious about what containers say on them in terms of how much is in there. So here's some soy sauce. If you look really carefully here, it says here on the outside of the soy sauce that it says it's 380 milliliters of soy sauce when it was purchased, when it was bought at the store. So that's really liquidy. Here's some olive oil. And if you look really close, it says the volume is 1,000 milliliters, which is 1 liter. Interesting. And down here on the counter, there's some vegetable oil. And this says there's 3 liters. Okay. And here's another cupboard over here. I've got some salt. Now this doesn't say liters. This says that there's 1 kilogram of salt in here. So that's measuring with kilograms, not liters. And salt is not a liquid. Here's some peanut butter. What does that say? 1 kilogram. Okay, again, just like the salt, the peanut butter is not measured in milliliters or liters like the other things that I found over in this cupboard here. I'm beginning to put together a theory here. A theory or a hypothesis. Here's my hypothesis, that if the container is holding something that has got liquid in it, like water, liquidy water, that I think it's going to say liters or milliliters on the container. So there's soy sauce, there's oil, more oil here, and then over here, salt is not a liquid, it's a solid, little tiny grains. That's kilograms. Peanut butter, that's not a liquid, but it's not a solid either, but it's certainly not a liquid, and it's kilograms. Let's go up a little bit higher here. Here's some vanilla extract that's sometimes used in cooking. Now that looks very watery. And, 500 milliliters. So that's measured with milliliters. So again, my theory is that containers that contain really liquidy stuff will be measured in liters or milliliters, and containers that contain more solid stuff like salt or maybe stuff that's not really watery. Peanut butter is not watery, it's sort of thick. Those are measured with grams or kilograms. So here's some dish soap for washing dirty dishes, and this is pretty liquidy. You know, you can pour it out the top. It's not as thick as peanut butter, and it's not salt, and it says milliliters, 800 milliliters. I'm in the fridge now. Here's some hummus. Now hummus kind of reminds me a bit of peanut butter. It's not liquidy or anything, it's sort of thick. And look at that. It's not milliliters, it says 454 grams. And I found something else in my fridge here. Here's some apple juice. 100% pure apple juice. Where does it say? Oh, there it is. 2 liters. So it doesn't say grams or kilograms, so apple juice it's pretty liquidy, so it's also measuring in liters. So here's some margarine, and it's kind of thick like peanut butter is. It's not watery, and it's not measuring using liters or milliliters. It's 907 grams. Okay, here's some yogurt that I found in the fridge, and this says 650 grams. And yogurt, yeah, I guess sometimes it can be watery, but it's much thicker usually than water. This is cream, and cream should be more liquidy, and it should be measured, if my theory is right, it should be measured with milliliters. Here we go, let's see. Or liters. There it is. 1 liter, which is 1,000 milliliters. Here's some sugar. You might have sugar at your house too. Sugar is a solid, it's little grains like sand, and it's not milliliters, it's measured with grams. So 2 kilograms, or 2,000 grams. Here's some more vanilla extract. It's pretty watery. What do you think it's going to be? Is it going to be measured with grams or milliliters? It's measured with milliliters because it's very watery. Here's some soup that I found. Now soup is pretty liquidy, but there's solid stuff in there too. So what do you think? Do you think that's going to be measured with grams or milliliters? Measured with milliliters. 284 milliliters of soup. Here's some cocoa. So cocoa is used to make things that are chocolate. It's a powder. It's not liquidy. So do you think it's going to be measured with grams or milliliters? This one's measured with grams. 227 grams of cocoa powder. Here's a bar of soap, which is a solid. It's hard. So do you think this will be measured with milliliters, or do you think it will be measured with grams? There it is on the side, 113 grams of soap. Here's a can of crushed tomatoes. So I could open this lid and I could pour this out into a bowl. So I think it's pretty liquidy. So do you think it would be measured with grams? Or do you think it should be measured with milliliters? 796 milliliters. Okay, here's the final one. This is a bag of pasta. So, do you think this will have a measurement in grams, or do you think it'll be measured with milliliters? "900 grams. So look around your kitchen and see if it works at your house. If things are really watery, do they use milliliters? Or if things are more solid, is it measured with grams?